acids and bases, weak versus strong. We'll now have an introduction to the differences between strong and weak in terms of acids and bases. By the end of this video, you should know the theoretical difference between strong and weak and know how to identify which acids are strong and which bases are strong. Through exclusion, those that are not strong are weak, so you'll therefore be able to identify those as well. Of course, after a period of memorization. Let's think back to all those happy couples that went off to college. Many of them broke up for good, never to go back, while others were continually breaking up, dating others, getting back together, and breaking up again. They are the it's complicated couples. We can think of this in terms of our acids as well. Strong acids and bases ionize completely, while weak acids and bases only ionize some of the time. It's a dynamic equilibrium. Let's look at this a bit more in depth. For strong acids and bases, I said that this is a complete breakup. In other words, all of the H pluses are coming off from the species. For example, if we have HCl, which is a strong acid, we can say that all of it turns into H3O plus and Cl minus. This is a bit of an oversimplification. In reality, almost all of it's ionizing. Technically, there is still an equilibrium, but the equilibrium is so far to the right that we can make an assumption that it's 100% in most cases. We'll talk later in another video about what happens if we can't make this assumption. Here is a list of the strong acids. I've drawn a few of the line structures out to remind you what these look like. You can see the possible places for the hydrogen to be removed. One note about H2SO4. Only the first hydrogen that is removed can be treated as a strong acid. The second one is weak. We'll talk more about dealing with polyprotic acids later in the chapter. The strong bases are a bit easier to remember. They are the hydroxides of the first and second groups. The first group is simple to deal with. They simply break apart into the plus and minus ions for all cases within normal limits. The second group of hydroxides are a bit more complex. That's because they actually aren't very soluble. However, if they do dissolve into water, then they will in fact ionize completely, making them a strong base. For this chapter, we'll only give you the group 2 elements with the hydroxides that are under the limits of solubility. In other words, they all dissolve, and so you can assume that they all break up into the positive and minus ions. After we have learned about solubility equilibria in later chapters, we can start discussing these if more than can dissolve is added. Weak acids and bases. We write an equilibrium arrow because in these cases the equilibrium lies quite far to the left. Even this picture is a giant exaggeration of how much the ions will be ionized for the sake of me having enough room. These calculations are a bit more complex, and we'll tackle them in the following videos. So how do you know which acids and bases are strong or weak? Well, you're going to memorize the strong and therefore know that the rest are weak. You can use the lists from earlier in the video, your book, or the internet to help you remember which ones are strong and which are weak, especially for the acids, which are a bit tougher to memorize because they aren't just simply one group combined with an H plus or hydroxide. If you remember that the group 1 and group 2 combined with hydroxides are strong for the bases, then you're all done memorizing for the strong and weak bases. Now that you've watched this video, you should be able to explain the theoretical difference between strong and weak acids and bases in terms of their equilibria. After a bit of memorization, you should also be able to identify the strong acids and bases, and therefore by exclusion, know that all the rest are weak.